Hi everyone, Grant K here for the Flame Premium Learning channel. In the previous video on Lightbox, we looked at the basic workflow of applying Lightbox shaders in action. As a quick recap, Lightbox are GLSL shaders that are cast through lights within the 3D composite. Lightbox is aware of the 3D environment, and you can even use the 3D Z space to control the decay of the Lightbox effect over distances relative to the light. But did you know that Lightbox also takes into account the physicality of 3D geometry in the composite? In this video, we take a look at the Lightbox Normals that will help you understand how 3D objects react to casting shading effects. If you would like to follow along, please click the link in the YouTube description to download the setup. Alternatively, if you're watching the podcast version of this video, then type the link displayed in your web browser. So go ahead and load the downloaded setup and switch to a dual screen configuration. This scene is a set of 3D geometries in 3D space that we will develop with Lightbox. Just so that you know what settings we are using, switch to the Node Preferences menu. Under the Shading header, you can see that Shading and Scene Ambient Lighting is enabled. Intensity is at 100%, and so is shading. This means that there is ambient light in the scene, and all 3D objects are currently being shaded. This is all being done without adding a light into the scene. Ambient occlusion is also enabled in the Render Output menu for added effect. Now switch back to the main menus and choose the Action Bin menu. For the purposes of illustrating this example, we'll be casting 3D noise into the scene with Lightbox. But you can use any Lightbox shader that comes with Flame Premium or download it from a third-party developer. Switch to the Lightbox tab in the Action Node bin. Choose the Noise 3D node and drag it into the Action schematic. So currently, this light is casting a noise pattern into the 3D scene. You could say that the Lightbox is being projected into the composite through the light. Now double-click on the light node. Set the spread to 45 degrees. Reposition the light to the right of the camera and angle it down towards the box geometries. I suggest switching to the top view with Shift 4 and repositioning the light so that it faces the front of the geometry. Now have a close look at the result view. As the Lightbox is cast through the light, notice how the different normals of the 3D geometry are affected more than others. If you haven't heard of this before, normals refer to all sides of an object and their orientation in 3D space. This is a fundamental part of lighting in 3D. In the case of Lightbox, all the normals that are facing the light are more affected compared to other normals that are not facing the light. Compare the different sides of the boxes. The front side of the boxes are picking up the Lightbox shader, whereas the side normals face away from the light, therefore the Lightbox effect is more transparent. So as a Lightbox is cast through a light, the shader's transparency is based on the orientation of every side of a 3D geometry. Now this happens by default when using Lightbox. If you look at the rendering header in the Light menu, you will see that Lightbox Normals is enabled. When you disable the Lightbox Normals setting, the Lightbox shader evenly shades every side of the 3D geometry. The effects of the Lightbox shader will be uniform irrespective of the object's distance in relation to the light in 3D space. So this is applying a more global kind of effect. But please remember that you can limit this by the light cone, Lightbox selectives, or light links. Now you have a bit more flexibility with the Lightbox Normals. In the Light menu, switch to the Lightbox submenu. If you haven't already done so, re-enable the Lightbox Normals. In this menu, you can adjust the influence that the normals will have on the Lightbox transparency. So this gives you a bit more control how the shading is applied. But if you really want total control over the Lightbox Normals from a programming perspective, you can enable Override Normals. This disables the standard Lightbox Normals behavior in action. Using the Lightbox API, you can program a custom shader that controls how normals are handled in action. This allows you to create different effects, as well as change the results from the action renderer. Your custom Lightbox can even turn the override normals on by default. If you are interested in this, please refer to the documentation on programming with the Lightbox API. Just for clarification, overriding the normals is not like turning them off in action. For example, turn off override normals. Now disable the Lightbox Normals. So this is a uniform shading from the Lightbox shader. But any faces that are 100% facing away from the light are unaffected. You can see this more clearly in the top view. When you override the normals, every side visible or not is affected by the Lightbox shader. Now let's finish this video by giving the objects a texture feel. Ensure that you re-enable the Lightbox Normals. If you orbit the result view, you can see how the Lightbox is cast on all 3D geometry surfaces. Just undo or reset the camera back to the default position. Switch back to the action schematic. Select the light and shrink the spread to only surround the boxes. You can also adjust the parametric falloff to soften the light cone. Now what's great about the Lightbox shaders is the ability to blend them into the 3D scene. In the Lightbox menu, change the blend mode from no blending to overlay. This has a texture feel we're after, but it's still too intense. So switch to the shader menu and drop the mix value to 75%. If you press the preview button, you will see that we have given the 3D composite a more interesting look as opposed to clean graphics. As a final tip, if your 3D objects are also textured with an additional normals map, the Lightbox shader will respect those values as well. The normals map, as well as the normals of the geometry, attenuate the Lightbox shader effect. So in conclusion, Lightbox shaders are not only aware of the 3D space, but also the actual 3D geometry. You can achieve interesting look development that not only takes into account the pixel data, but also its position and orientation in 3D space. Comments, feedback, and suggestions are always welcome and appreciated. Thank you for watching, and please subscribe to the Flame Premium Learning channel for future videos.